All right, so we're at pre-calculus 32.3, number 7a. We have to solve a radical equation. That's what 2.3 is all about. Two different ways to do that. One is algebraically and one is graphically. So algebraically, let's do that first. So let's do the Alg method first here. And what we want to do is we want to take this equation. The radical is already isolated, so that's great. So let's let's square both sides. And so when we do that, we get 8 minus x on this side. And please don't put x squared plus 36 on this side. Please don't do that. Okay? It's tempting. Very, very tempting. And I think it's tempting because, you know what? When we squared this, we just kind of used that term and this term, and it's all good. But this one is a binomial times a binomial. So remember, it has to be x squared plus 12x plus 36. All right? Now, in order to solve this, this is clearly a quadratic type equation. Now it's not a radical equation anymore. We got rid of that. And now it's a quadratic type equation, which we know how to solve for. Let's get everything over to the one side here. So I'm going to keep that x squared positive. I like that first term positive a lot. So I'm going to add x to both sides. It's going to make this 13x. And I'm going to subtract 8 from both sides. So that's going to be what, 28, I guess? Something like that. Okay. So can we solve this by factoring? That's the question. Can we solve this by factoring? What do we have for factors of 28? Are these whole number factors, right? That's the thing. Are the binomials, are the intercepts, let's say, are they whole numbers, or are they going to be a little more complicated? So are there any factors of 28 that add up to 13? That's what you want to look for. We've got 14 and 2. That's not going to add up to 13. We've got what? 7 and 4. That's going to add up to 11. So can we get to 13 anyhow? Geez, 13 is 10 and 3, 12 and 1, 6 and 7, right? 8 and 5. No, that doesn't get there. Okay, so what we're going to need to do then is we're going to need to explore our quadratic formula. So x equals negative b, that's negative 13, plus or minus the square root of b squared minus 4 times a times c. And we're going to see if there are any factors at all here in a second, all over 2a. Now, this b squared minus 4ac is what we call our determinant, right? And that will determine the nature of the roots. So I'd like to do that one first. I'm going to do that one over to the side here. So I'll just do that on my calculator maybe first. So what do we have here? We have 13 squared, 169 I believe, minus, I'll put this in brackets, 4 times 28. All right. Oh, we get 57. Okay, so it's positive, so that's great. That means we're going to have two different possible roots here. So plus or minus root 57. 2 over 2, okay? Okay, so these roots are irrational because root 57 is not a perfect square, so we can't boil this down to a fraction. It's going to be an irrational. So what does it say? Note restrictions, solve algebra. Okay, so we can write this as a decimal or as a fraction like this, or an equation like this. So x would be minus 13 plus root 57 over 2, or negative 13 minus root 57 over 2. Now, to solve this graphically, probably what we should do is have our graph here. And like I said, you may have a graphing calculator for some of these assignments. You may not have a graphing calculator for some of the assignments and tests that I give you as well. So we need to know how to solve this graphically manually, okay? So we need to know how to do that. So I'm going to do that with you here. Obviously, these answers are only going to be approximate when we solve graphically manually, but let's give it a try. So root 8 minus x, okay, so root 8 minus x. So if you do a quick table of values here for this left side, and I'm going to graph this left side by itself. So 8 minus x. So let's see, are there restrictions? Are there restrictions? Well, the question asks for restrictions. And on this side, we know that 8 minus x has to be greater than or equal to 0 because it's underneath the square root sign. So if I add x to both sides, that's x less than 8. Or this is a better way to write it, x less than or equal to positive 8, right? Because you always read from the x side. So x has to be less than or equal to 8. If it's greater than 8, like 8 minus 10, we have a negative number, so that's no good. Okay. So if I make it 8, then we've got 0. Okay. If I make x, let's see, if I make x 4, 8 minus 4 is 4. Square root of 4 is 2. Okay, awesome. Let's see, if I make x, well, I guess 8, 4, let's go 0. So what's the square root of 8? Well, root 8 is going to be almost 3, I guess, just under 3. Square root 8, 2.828, so which equals 2.828. So I've got a few points there. I know this is a radical function, okay? So let's see what happens. 8, 0, 2, 3, 4, 5, 6, 7, 8. Okay, 8's going to be over here. I'm going to put 8, 0 over there. 4, 2, 1, 2, 3, 4, positive 2. And 0 and 2.8. 1, 2, 2.8. Okay? Whoops. 2.8. Now, if I went further, we would see that we would have, I guess, looks like something like this. We have a radical-looking equation. Okay? And yes, you're going to maybe put another point here so you can be very exact. I'm a little bit wavy with my tablet here. But you want to make a nice smooth curve exactly through these points as best that you can. And maybe I'll just try that one more time to see if I can do that a bit better. Okay. And then x plus 6 is going to be our next one. I'll do that in black. That's a slope of 1. And we have a y-intercept of 6. 1, 2, 3, 4, 5, 6. And so down 6 over 6. 1, 2, 3, 4, 5, 6. That gives us a slope of 1. And so when you connect these points very carefully, right, then you see that, whoops, what happened there? You see that we're going to have an intercept right about here somewhere. Okay? Right about there. Now, the nice thing about the graph, is that you can see whether you have one or two real solutions. Okay? So if you notice these two, if you notice those two, we didn't check to see if those two were actually going to be real. We didn't check. We could have, should have, if we were only doing this algebraically. But because we're doing this graphically as well, this graphically is kind of our check as well. So guess what? It looks like we only have one solution here, doesn't it? Straight line, and the nature of this graph keeps going. This graph keeps going. See? So one of these is going to be rejected. All right? And so what we're going to want to do is try and find out what x value this is. That's going to be close to 1 to negative 3. So about negative 3, approximately, right? So which one of these would be approximately negative 3? I'm guessing probably this one, maybe. Wow. My computer loves me. This keeps dying on me. All right. So did we calculate this yet? No, not really. So negative 13 minus root 57 divided by 2. Okay, so that's going to be about negative 10. Okay, well, that's not negative 3, is it? So let's check the other one. Oh, that was the negative one. So negative 13 plus root 57 divided by 2. Look at that, negative 2.7. So negative 2.725, according to our graph, it looks very, 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 very close. And again, if you were to draw this super exact and add maybe one more point over here, then you would get something just, and even this one is just under 3, right? 1, 2, 3 is over here, so maybe just underneath 3 right here. So 2.7, it's going to be this one right here is your answer. Hey. Start normally? Oh, I wish. Yeah, it'd be nice to start normally. and keep going normally. Okay, any questions about that one? Does that help answer your question there, Jason? Okay. All right. 7a.